high above a snowy work area. A suspended metal step frame takes extra load as its anchors begin to give way without warning. Suspended metal steps rely entirely on secure anchor points, stable connections, and verified load limits. On a busy street, a rider attempts to steer his motorcycle around a massive open pit in the middle of the road, misjudges the gap, and loses control. Two-wheeled vehicles depend on stable ground, predictable steering, and enough clearance to keep both tires aligned. When a large open pit cuts into the road path, the remaining space becomes a narrow balance challenge. A small misjudgment in spacing can move the tire path toward loose edges, uneven pavement, or broken ground. The safer choice is to avoid tight clearance beside deep road openings. Slow down early, create a wider route, and never force a heavy two-wheeled vehicle through a path that does not give stable tire room. At an industrial demolition site, an excavator chips away at the base of a large concrete silo as the structure begins losing support. Tall concrete structures carry enormous weight through their lower foundation. Once the base is weakened, the upper mass no longer has a balanced support path. A small lean can rapidly become a full directional collapse when the remaining concrete can no longer resist the weight above it. The hazard is not just the fall itself. It is the uncertainty of direction when the base is removed without controlled sequencing. Demolition must follow an engineered plan. The collapse path, machine position, exclusion boundary, and structural weakening sequence must all be controlled before the first section is removed. Inside a motorcycle shop, a tall, unsecured metal bar stands upright near the entrance before its narrow balance point begins to shift. A heavy metal bar may look stable while it is standing still, but upright storage creates a fragile center of gravity. The taller the object, the easier it is for a small vibration, slight contact, or uneven floor surface to disturb its balance. Once the center of gravity moves outside the base contact point, gravity takes over and the object accelerates downward. The safer approach is to properly secure loose equipment. Tall tools, bars, pipes, and solid metal objects should be laid flat, racked securely or restrained with brackets so they cannot tip into the active workspace. Behind an open delivery truck, a heavy flat load is handed down as gravity begins to overpower the manual transfer. Large flat materials become difficult to control when they tilt downward from a truck bed. The weight shifts away from the support point, and gravity begins pulling the load into a steeper angle. Manual handling becomes unreliable because the force increases faster than the position can be corrected. Once the material tips past its stable point, it can move as one uncontrolled mass, creating a hazardous path beneath and around the unloading area. Heavy materials should not depend on grip strength or improvised positioning. Use mechanical lifting support, team planning, stable staging, and controlled lowering equipment. Outside a street workshop, an open flame reaches a used metal barrel as hidden vapors build into a sudden pressure release. Empty metal containers are not always safe, simply because the visible liquid is gone. Residual vapor can remain trapped inside seams, corners, and closed spaces. When flame or heat reaches that vapor, pressure can build rapidly against the rigid container walls. If the container cannot vent safely, the internal force may release suddenly through weak points, sending the metal casing and contents into uncontrolled motion. Used barrels, tanks, and sealed containers must be kept away from ignition sources until they are cleaned, vented, and verified. The safest approach is to regard every closed container as a possible vapor space until testing confirms otherwise. Inside a factory floor, a crane-lifted panel loses support after release as the vertical load begins to tip sideways. Tall panels are unstable when they rest on thin edges without bracing. While the crane is connected, the overhead rigging helps hold the load upright. But once the crane support is released, every force transfers into the base. If the bottom is not blocked or secured, the panel can tip as its center of gravity moves beyond the support line. Vertical loads need fixed bracing before the crane is detached. Secure the base, verify the lean, control, and keep the area around the panel clear until the load is fully stable. At a construction site, an unstable ladder setup meets the recoil of a power nailer as the working position loses control. Tool recoil can disrupt a weak climbing position almost instantly. A ladder provides access, but it does not provide the same stable surface as a platform. When a power nailer pushes backward during use, that force travels through the stance and into the ladder. If the ladder is not secured, level, and properly positioned, the working surface can shift at the exact moment tool control is needed most. Before using powered tools at height, stabilize the access equipment. Secure the ladder, maintain balanced footing, and use a wider elevated platform when the task requires force, reach, or repeated tool operation. On a smooth factory floor, a scaffold is pushed forward as the weight above it becomes increasingly unstable. Tall wheeled platforms possess a highly sensitive center of gravity. The higher the load sits, the easier it is for movement, braking, or floor irregularities to shift the center of gravity. A small bump under the wheel can stop the base while the upper mass continues moving forward. That difference between the base and top section creates a tipping force that can quickly overpower the platform's stability. The safer control is to lower the elevated sections before movement begins. Clear the platform, reduce height, check the floor path, and move slowly. On a street in Nantou County, a dark bag is loaded into a garbage truck compactor before dry ash bursts out into the loading area. Dry powder behaves differently from ordinary solid waste. When sealed inside a bag, it can trap air and fine particles under pressure. A garbage truck compactor applies sudden force against the bag, compressing the contents against steel surfaces. If the plastic tears quickly, the trapped air pushes powder outward in a large cloud. Powdery waste should be dampened, labeled, and handled separately when possible. Unknown contents should be checked before compaction. Keeping the loading area controlled reduces sudden dust release and prevents visibility loss around active machinery. On a factory floor, loose fabric moves too close to a spinning industrial roller as the machine's pull force takes over. Rotating rollers are designed to grip and feed material. Their surface friction pulls objects toward the in-running gap with continuous mechanical force. When loose fabric reaches the roller, the machine can catch it before there is time to correct the position. The roller does not need a large opening to create a hazard. A small loose edge is enough for the rotation to begin pulling material inward. The safest approach is separation from moving parts. Loose clothing, hanging fabric, lanyards, and unsecured material must stay away from rollers. Inside a cable factory, material is guided toward a spinning spool as a rotating force catches loose material near the winding line. A spinning spool stores constant pulling energy while wrapping material at speed. The rotation is smooth, but the force behind it is strong and continuous. Any loose material near the winding line can become caught and drawn toward the center of rotation. Once the spool grips the material, the movement follows the machine's winding path, not the intended handling direction. Spool work requires strict clearance. Stop the machine before adjusting stuck material, keep loose items away from the winding line, and use tools or controls designed for safe feed correction. Outside a building, a flaming pole reaches a bee nest beneath the eaves before the heated structure breaks loose overhead. Applying open flame to an overhead structure creates multiple hazards at once. Heat weakens attachment points, changes the strength of the nest material, and adds falling debris risk below the roofline. Once the support fails, gravity controls the movement. The burning material can drop directly into the area beneath the eaves, while smoke and heat reduce visibility and reaction time. Homemade burning tools are unpredictable around elevated hazards. Professional pest removal, proper access equipment, and ground-level exclusion are safer choices. Before any overhead task begins, the area below must be kept clear, and the method must avoid uncontrolled heat exposure. Inside a busy warehouse, a reach truck travels with a raised heavy load as the machine's balance begins to shift. A reach truck is most stable when its load is low. When cargo is raised high on the mast, the machine's center of gravity moves upward. During travel, turning or uneven floor contact can create sideways momentum. If the elevated load shifts beyond the stable base, the machine can begin tipping before the movement can be corrected. Warehouse aisles make this worse because space is limited and load visibility may be reduced. The safest travel position is low and controlled. Lower the load before driving. At a forest road extraction site, a blocked log under pressure is cut as stored energy suddenly releases through the timber. Fallen timber can hold hidden tension and compression when it rests across uneven ground. A log may appear still, but internal force can be locked inside the bend, contact point, or trapped section. Cutting through the wood releases that stored energy. Once the cut opens, the timber can roll, spring, or shift along the easiest movement path. Before cutting loaded timber, identify the compression side, tension side, and natural movement direction. Use blocks, stable supports, and a clear escape route. The cut should be planned so released energy moves away from the work position. Inside a busy workshop, a massive metal cylinder hangs from an overhead crane before the lifting support unexpectedly fails. A suspended load stores gravitational energy the entire time it is hanging. Lifting straps carry the weight through tension, and any weakness in the strap, sling angle, or contact point can reduce the safety margin. If the rigging fails, the load path changes instantly. The cylinder no longer follows controlled crane movement. It follows gravity into the space directly beneath the lift. Safe lifting depends on inspection and clearance. Check slings for wear, confirm the load weight, protect straps from sharp edges, and use tag lines to guide movement from outside the drop path. Inside a busy hotel kitchen, a sealed boiling vessel builds hidden steam pressure as the container reaches its limit. Steam pressure can build quickly when heat is trapped inside a sealed container. As the liquid boils, vapor expands and pushes against the internal walls. If the container has no safe vent path, pressure continues rising until the weakest point gives way. At that moment, hot contents and fragments can move outward suddenly, turning ordinary cooking equipment into a pressure release hazard. Pressure control must come before opening, moving, or heating sealed vessels. Vent steam carefully, monitor temperature gauges, and never rely on guesswork when heat is trapped. Barriers, safe distance, and proper relief systems keep pressure hazards controlled. Inside a busy warehouse, a forklift emerges from a blind storage intersection as the crossing path becomes hidden. Warehouse intersections create risk when racks, pallets, and machine frames block the view. A forklift may be moving slowly, but its weight and momentum still require distance to stop. When a machine enters an aisle without clear sight lines, the crossing path becomes unpredictable. The hazard comes from limited visibility, heavy rolling mass, and shared travel lanes. Blind intersections need a strict control routine. Sound the horn, stop before crossing, check mirrors, reduce speed, and mark pedestrian walkways separately from forklift routes. At a shipping dock, a heavy crate is lowered by an overhead crane before the lifting straps suddenly lose tension. Suspended cargo depends on every part of the rigging system working together. The strap strength, hook position, sling angle, load balance, and crane control all affect stability. If one strap fails, the load can shift unevenly, overloading the remaining support. If all tension is lost, gravity immediately controls the crate's movement. The lifting area becomes unsafe the moment the rigging no longer supports the weight. Before lowering heavy cargo, inspect lifting gear carefully and confirm that straps are properly rated. Keep the dock area clear beneath the load. At a snowy rail crossing, a dump truck enters icy tracks as a fast-moving transport train closes the distance ahead. Rail vehicles carry enormous momentum and require long stopping distances. A road vehicle entering the track path must have enough time, traction, and clearance to move fully across. Snow and ice can reduce tire grip, slow acceleration, and make stopping less predictable. Once a train is close, the crossing path becomes a high-risk traffic conflict because the rail vehicle cannot stop quickly. Rail crossings require complete certainty before entry. Stop at the checkpoint, confirm both directions are clear, account for icy surface conditions, and never enter until there is enough space to fully clear the tracks without delay. At a street construction site, an active excavator swings near an open street as the rear work area becomes unsafe. Excavators have large blind areas around the rear, sides, and counterweight. During rotation, the machine needs space not only for the bucket and boom, but also for the rear swing. When walkways pass too close to active equipment, movement can become difficult to see and harder to predict. The hazard comes from blind machine motion, rotating steel mass, and unclear separation between work traffic and public access. Construction areas need visible barriers and controlled walkways. Keep the swing path isolated, use spotters when visibility is limited, and separate public movement from active machinery until rotation and digging have fully stopped. Inside a busy workshop, timber binds against a spinning table saw blade as stored cutting energy launches backward through the line. A table saw blade spins with enough force to cut dense material quickly. If the timber shifts offline or pinches the blade, friction can lock the wood against the teeth. Instead of feeding smoothly through the cut, the material can be driven backward along the blade path. Safe cutting depends on alignment and distance from the active path. Use a fence, riving knife, push block, and steady feed pressure. Keep the area behind the blade clear and position the work so kickback energy is not directed into the main standing path. Inside a steel factory, a standing steel coil shifts during hook placement as its narrow balance point begins to collapse. A steel coil standing upright carries dense weight on a narrow contact surface. Even when it looks still, its balance can be fragile. A slight shift during hook placement, floor contact, or load handling can move the center of gravity beyond the base. Once that happens, the coil begins rotating downward under its own weight. Steel coils need restraint before handling begins. At a loading dock, a loaded pallet jack moves onto a truck tail lift before the platform tilts under shifting cargo weight. Tail lifts are designed for specific load limits and balanced placement. When a loaded pallet jack rolls toward an unsupported edge, the weight can shift suddenly to one side or forward onto the platform lip. If that pressure exceeds the lift's stable range, the platform can tilt and turn into a steep slope. Before using a tail lift, confirm capacity, load position, wheel control, and platform level. Keep cargo centered, move slowly, and keep the surrounding dock space clear until the load is fully lowered. Inside a processing plant, ladder-based welding beside a massive silo creates a height hazard as balance and focus compete. Welding at height demands stable access, steady positioning, and clear control of tools and cables. A ladder can provide short access, but it is not ideal for sustained hot work. Bright sparks, hand positioning, cable drag, and narrow rungs can all reduce stability. Even a small lean changes the working angle and shifts the load on the ladder. Around large industrial structures, access conditions must be stronger than the task demands. For welding near silos or tanks, use a proper elevated platform whenever possible. Secure access equipment, control cables, and maintain three-point stability before work begins. Inside a warehouse, an overhanging wooden plank extends from a parked forklift as another machine approaches through the travel path. Long materials that extend beyond equipment create hidden lever hazards. The object may be stationary, but its overhanging end can reach into the active travel lane. When another machine contacts that edge, rolling momentum transfers into the plank. The material can then sweep around its support point and create sudden movement across the nearby area. The hazard is easy to miss because the forklift itself may not be moving. Long loads must be marked, shortened, supported, or stored outside traffic routes. Warehouse aisles should remain clear, and any overhanging material must be treated as an active obstruction until removed. Inside a factory, an industrial robot remains powered during testing as the robotic arm suddenly enters its programmed movement path. Industrial robots move according to programmed instructions, not surrounding awareness. When power remains engaged, the system can restart, continue a sequence, or move through a stored path without warning. The robotic arm may appear still during testing, but the energy source and control logic are still active. Robot work requires full isolation before access. Lock out power, verify zero energy, confirm motion has stopped, and use barriers that prevent entry during operation. Testing should only occur with controlled access, safe distance, and a clear understanding of the robot's programmed travel path. High on an industrial track, heavy machinery is inspected as a massive metal beam slides forward without warning. Track-mounted machinery can move with enormous hidden force. The travel path may look fixed and predictable, but the stored energy behind the sliding section can close gaps quickly once the mechanism activates. When inspection areas overlap with moving components, narrow clearances become pinch point conditions. The steel does not need high speed to create a major hazard. Its weight and mechanical drive are enough to overpower the available space. To keep learning from these important workplace safety lessons, make sure you subscribe and turn on notifications. Stay aware, stay safe.